Refractive index. Refractive index, it is the ratio of velocity of light in air to the velocity of light in medium. We denote it by C. Refractive index, we can define refractive index in two ways. One is absolute refractive index and relative refractive index. Now students, absolute refractive index is basically, it is the refractive index when we compare the velocity of light in medium with the velocity of light in air. That is when our comparison is with the velocity of light in air or vacuum. Then that refractive index, that ratio of velocities is defined as absolute refractive index. Uh, Absolute refractive index, that is refractive index of glass with respect to air, because as I told you that absolute refractive index, it is C upon Vm, that is the comparison is with the velocity of light in air. So absolute refractive index of glass is 1.5. That means this n is 1.5, and we know that C, that is C is 3 into 10 raised to the power 8 meter per second upon velocity of light in the glass, and in this way we can calculate the velocity of light in glass, comes out to be 2 into 10. Now relative refractive index. So relative refractive index is, if we define the relative refractive index, then it is when the comparison of the speed of light in one medium is with the speed of light in another medium. Then we say it is the relative refractive index. For example, for absolute refractive index, we are taking absolute refractive index of glass with respect to air. But here we are taking refractive index of water with respect to glass. So, or we can write it refractive index of water with respect to glass. Now, the two medias which in which we are comparing our velocities of light are different other than air, right? And this is known as refractive index of water with respect to glass. Now, as we know that we are taking refractive index as the ratio of the velocities of light in two different medias, right? So if we are saying that refractive index of water with respect to glass, then we will write velocity of light in glass to the velocity of light in water. So now we know that the absolute refractive index of glass with respect to air is given by C upon Vg. So here when we will shift the terms, we will calculate the value of Vg, that is the velocity of light in glass. It comes out to be C divided by the refractive index, absolute refractive index of glass. So we can write it here. It is basically with respect to air, as you all know. So it is like this, right? And when similarly we can calculate the absolute refractive index of water with respect to air, that is the absolute refractive index, because we are here having our velocity of light C. So this is V, that is the velocity of light in water, and when we will substitute, we'll get this ratio as like this. Now it comes out that relative refractive index, that is, we will say that the refractive index of water with respect to glass, right? It is the ratio of refractive index, that is the absolute refractive index of water to the absolute refractive index of glass. For example, now we want to calculate that refractive index of water with respect to glass, then it comes out to be like this, because the 1.3, it is the absolute refractive index of water, and 1.5 is the absolute refractive index of glass. So this ratio comes out to be 0.86. And as we know that water index is a unitless quantity because it has no units, because we know that it is the ratio of two velocities, that is meter per second, it cancels out. So it's a ratio, it is a unitless quantity, it is a unit. After refractive index, we know that whenever a light ray incidents on a surface, like for example, this is a glass, this is air. So to make it simple, we are taking the same example again and again. Now the light is traveling from air towards the glass, and now the light is along the normal. So what do you think? What is the path of this light? We all know that whenever a light travels through the normal, when it incidents on the to the normal, to the surface, then it goes undeviated. But when a light incidence on it in some angle, that is I, it makes some angle of incidence, then it bends towards the normal. Why this happens? Why it bends towards the normal, and why the path of incident ray which is normal to the surface goes undeviated? Let us try to understand why light bends towards the normal. Actually, what happens whenever light goes from one medium to another medium, light prefers to travel through the shortest path. So suppose the light is incident at an with an angle of incidence I at point A. Now at this point A, students, light has to travel through this medium. So let us say light is traveling through these 2 points A to B. Now what is the shortest path? We know that the shortest path between 2 points is the straight line. So this normal is the path which is the shortest. Therefore, the light ray which incident on this surface at some angle, it tries to bend towards the normal in order to gain the shortest path, right? When but when the light incidents at normal, that is at this point A, it is normal to the surface. Then it is already entering the surface at the point where it is going to travel through the shortest distance. That's why there is no deviation from the path. That's why whenever a light is incident normal to the surface, it goes undeviated because it is already following the shortest path. Thank you.